welcome to the two of you. And I have to ask, I'm talking to I don't know, Russ, do you want me to call you a glass legend? I don't know
I
if
don't,
that's
I don't
fair,
know.
but when I say glass legend, I say somebody that's really been around, that's seen a lot. And funny enough, Richard I connected now at two conferences.
Yeah.
So I said you two have to know each other. So enlighten us all on where the two of you met.
I think the first time I ever saw you, Richard, was at an E1300 meeting in New Orleans.
That's the first time we met in person. Yeah.
That's right. That's right. We might have crossed paths prior to that, but the first time was certainly over a decade ago. I think it might even be 15 years. So we've been in contact, yeah, for the period since, and we've had opportunities to look at various glass issues together. I think Richard's history, and I've been happy to participate when I can in his efforts. And in the meantime, I've continued with my own practice. So we've had an opportunity to share notes over the years.
And thank you for the participation you have had, because there are plenty of people that happily look at it and say thank you very much, and then there are people that actually say, here's some things you should look at and improvements to be made, and hopefully they're all bound in the new draft, which is out there. So thank you, Russell.
Yeah, you're welcome.
Richard, to what extent, at least today, and I'm not speaking about your past, but when I say today, within the past 18 months and beyond, are you really in the project weeds versus now at a sort of different level, higher level, more focused on packaging everything you've learned? Obviously, with your book, it's a different initiative, but on a different trajectory now.
At a personal level, yes, we're still doing lots of engineering and projects and work around the world and around the US. Working with some very well-known architects and doing some enjoyable work. So then we've got the structural design manual. So that's the green facade side of things. And then on the structural glass design manual, that's been about 16 years in the making, and spending time talking with a lot of people. Too numerable as to put on the list, and if I started naming certain people, I'm sure I'd leave people off. So I'm not going to do that, except for perhaps the co-authors and editors, which is Andrew Crosby and Terry McDonnell, who have helped me see this through to the end, and actually have this belief that the industry really needed it, and it's worth the effort, and it fills a gap which nothing else really does at the moment. So it's been a long time coming, and part of the reason for that is we wanted to make it right, and we wanted to talk to a lot of people. And you get a comment of, oh, you've got to have this in there, or you've got to have that in there, and so then we work through it. And some of those questions that people have don't have simple answers, and that's part of the challenge with glass. And you've got things which are okay here and they're not okay here. How do you reconcile those two things in a guide which says this is reasonable here and not here? And a lot of it really comes down to consequence, reliability and consequence. And that's kind of been the thing which has been different about glass. It's tension controlled, not compression controlled. And you have to approach it differently to other materials.
Because the technology and the product offerings are now moving at a greater rate than codes are evolving and changing.
Yeah.
How, beyond the two of you and beyond, small subset firms and specialists, how can people make informed decisions with newer glass technologies if they don't have referenced codes, specifications, rinse and repeat documents to then go back within their architectural library? What are you guys seeing in terms of, product trajectory, informed project decision making, and do we need to sort of bring that a little bit back to equilibrium?
Certainly the technology's changed. When we had little disc glass and the windows were this size in Georgian era, if it broke, it broke. Who cared? The wind got in a bit. And now we can buy things that 48 foot by 12 foot, and you break one of those and it's a completely different story. When you get into big pieces like that, you're generally dealing with specialist engineers that make sensible choices because they've had experience doing that thing. People don't invest that kind of money in a single piece of glass without having experience on it. But what we're seeing at the other end is things which people used to go, oh, I'm comfortable with this. They're now going, well, I'm comfortable with this and I'm comfortable with this. And you see some interesting decisions where people go, well, it's only 20% bigger than I did last time. But you do that next time and it's 40%, and the next time and soon it becomes double the size, and eventually gets to the point where if it breaks, it has consequences. And people don't realize when they're drifting over this limit of, I should actually change the way I'm doing this. And so I think part of the challenge of this is, where do we draw the lines? And there is definite shades of grey in terms of where you do that. It might be okay in this circumstance and not okay in that circumstance. But, if you took a piece that's 48 foot by 12 foot and you have it as a monolithic, fully tempered, if that thing breaks, it's ugly. So, generally it's laminated for strength just to get there. But there are times in between where I once saw somebody showed me this beautiful glass staircase in Thailand. It was monolithic, fully tempered treads on monolithic, fully tempered stringer. And I said, "Are you going to go up it?" I go, "Hell no." I go, "But I thought you said glass was really strong and you can trust it." I go, "When it's designed properly." Okay, so if you can get people to realize the issues at hand and ask the right questions, then they'll usually come up with the right answers. And so this is partly getting people to ask the right questions, give them a framework that they can talk with their clients, classify it, what level of robustness are we building into the system? And if you can actually just start with these options, I've had post-failure situations, you go to the client and go, "Oh God, if I knew that I could have laminated glass and it wouldn't fall off my building anymore, of course I would have done it." So we've just got to be aware of making decisions for the clients that the client wouldn't have made for themselves.
So I want to go in, and I saw your reaction, Russ, and I wanted to hear your response. Here's the framework of where I'd like this discussion to go. And I do want to get into the weeds, because sometimes I get a critique, you're a little too, elementary, it's a little boring. Okay, yes, same questions. Other people are like, it's way too much, like slow down. So with you two on, I want to focus on pushing the envelope when it comes to performance. And the two areas I want to look at are technologies we're seeing around thermal performance, obviously, but given things like heat mirror, which I've been seeing more people talk about, thin triples and quads, and then VIG. So newer technologies to combat some of that. So that's to start part A. Part B, a little bit in terms of the hurricane regions as it relates to laminated inner layers and what we're seeing to advance that side of the industry and make it a little bit more accessible. So to start on the thermal side, there's one point, you have a lot of experience with our German friends, Russell, where they just go deeper, bigger cavities, bigger thermal breaks. Let's add a third light. Let's add another, a third low E coating. And it's just bigger, more to get to better thermal targets. Now we're seeing the other way, things going the other way, where we're going lighter, we're looking at different materials and completely new assemblies entirely. So as a glass specialist, how comfortable are you pushing a newer technology without an extremely long track record? And B, do you think the industry is catching up to adopt some of those alternate technologies that can help us get to these solutions?
Well, I think the good way to start answering your question is to tag off of what Richard was just talking about. And this you tend to hear from me every time we talk, which is that the sooner you get important information in front of the client so that they can make decisions, the better. And some of the biggest problems in projects are when the facts aren't given to the owner quickly enough. And so I think making decisions about the risks and rewards of different types of approaches to glazing falls into that as well. I won't say more on that because there are too many sound bites of me saying things like that. But in the case of thermal performance, what we're finding is that the more complicated, the more planes of glass that you use, the more the knock-on effects become sensitive. For example, we see a lot of people concerned about polarized light. We see a lot of people concerned about anisotropy and birefringence, and we see them weighing the thermal performance versus, let's say, visible light transmission and color than we do about the thermal aspects of it in themselves, because we know there's a limited achievement we can get with U factor, a limited achievement we can get with a combination of U factor, solar heat gain, and color or treatment, let's say. So for a lot of the projects that Avro is working on, which are typically high-end projects with big glass, and we don't have to go over the examples. One of the things that we try to do is we try to make it such that the owner is aware of what the range is that they can expect. Mm-hmm. And these are the kinds of projects that when there is a piece of glass that falls within the specification is installed and still has a problem, the owner will say, "I'll just simply replace it," as opposed to those that run into real contractual problems when you have something that's, say, a single panel that's not consistent with the rest and nobody wants to do anything about it. The projects that I'm that Avro is currently involved in are ones where something needs to change, we change it. So that's a good thing. But I don't think that's available to every project. When it comes down to looking at the track record of newer proposed systems, I do think that it's important to have a reference. It could be as simple as giving a client a sense of what the relationship is between solar heat gain, U value, and visible light transmission, which is a very basic thing if you think about it. But if they don't come to grips with it, they can very easily be disappointed by the end. We find that putting film layers in the airspace is one thing that is being considered on some of our projects. But in the end, I think that we always, and this is just Avro's way of practicing, we always go back to basics. And we try to make the simplest IGU makeups with the most competent coatings and consideration for what the owner wants to see when they look at the glass. So high transparency, decent U value, U value that we can then pass to the mechanical engineer so that the mechanical engineer is part of the enclosure design. And I don't know if that's ever been discussed, but for us, it's something we discuss as much as we can. And then to consider, it's not always in this sequence, but then to consider solar heat gain and how to control that, whether it's benefited already by the architecture or whether it's something that has to be done as a treatment. And the last thing I'll say is that there's always a phenomenology that comes with glass. I don't mean to be overly philosophical about it, but the idea that a panel of glass is transparent, but that it has a color or that it has an appearance is so important to a client. It's so important to an owner. I can't tell you how many times a client has immediately repulsed using a frit and then later realized that if you put a frit facing the sky, you can't see it. And so I think that there are all of these sort of aspects that go into specifying glass, whether that's in the weeds of the technology or just in the weeds of making a proper specification. These are some of the considerations that we make.
On this topic of thermal performance, what are some of the biggest trade-offs you see being made? Maybe it has to do with visual light. Maybe it has to do with now you have to add a third pane, so you have an additional perimeter seal, so you risk, losing that hermeticity. Did I say that properly? Losing the performance of that hermetic seal. So, what are some of the trade-offs inherently that as we ramp up this whole idea of achieving better U factors and lowering our mechanical loads, the counteracting trade-off that comes along with glass decision-making process?
I mean, there's some interesting projects when it comes to that. And part of this is actually looking at the size of the window. And we talked about bigger glass. And the perimeter of the glass with the spacer and the frame and everything has lower performance than the center of the glass. And so, ironically, on one hand, people go, oh my God, you've got bigger glass. I've got so much more area going through the glass. But as you get bigger glass, the perimeter area ratio also drops. So you've got multiple things which are competing in terms of what it is. And sometimes in certain environments, solar harvesting can actually be beneficial. So I think to actually say in a generality, there are multiple things that need to be considered, like what is the climate? What's the orientation of the building? What's a good face to put this on? Where's the position of the light getting into the depth of the floor plate? So these are things which can actually play with how the glass is used effectively. But the other one which I want to throw in there is, do we have an energy problem or do we have a carbon problem? And every time we start adding extra layers of glass, we're actually adding extra embodied energy into it. And for somewhere like Seattle, where I am, if you're in Seattle downtown, it's 95% green electricity. The carbon payback on an extra light in that environment is really long. But if you take that into the Midwest where you've got coal power and it's really dirty, the payback's really short. And so if you're thinking about this, you really want to be thinking about where's my building and not just what's the answer for a piece of glass, because it's different everywhere. But how does that work into my particular building in my particular city and location, and what are the opportunities and what are the risks? Now, we're playing with technologies and we're talking about things. One of the things which one of my clients does not like in a residential sense is having 6 layers of reflection in a residential environment.
Yeah.
And so then you sort of start throwing anti-reflectives as an option. And some clients will love it. And some people will say, well, I've got rid of a lot of the reflection, but the reflection that's left is fluorescent green or fluorescent pink. And I really don't want to look like that, nor do I want my candle on my table to look like that. So they find that actually more disturbing than having multiple reflections. And so I think, where there is a good benefit of that is if you've got a low E coating that pulls it down in a neutral sense. So you've got less than 4% surface reflectivity, but you're not necessarily down into the less than 1% where you've got a selective reflection. Then you're kind of getting the U value benefit and the lower reflectivity, and you're building a unit which is pleasing to the owner. And so these are some of the tricks and games that we play in order to get from not just efficiency, but what is most desirable for a given project.
Seattle's a rather moderate climate zone in general, though. And as you said, there's very green energy source availability. So what has driven this push? And maybe it's local jurisdictions, local influence, the right people in the right seats, but
Right.
the code progression has been, accelerated beyond 90+% of the other jurisdictions in this country. So
Right.
do you think the current energy codes as it relates to glaze systems adequately meets the needs in commercial buildings in Seattle? Or is it a question of, okay, if people are just going to build as they want to build as cheap as they can, and for the most part, and legally comply with code, we need to ratchet up the baseline to overcompensate for maybe where some of these decisions are going to be made?
Well, there's multiple things that come into this argument, of course. And Seattle itself is like 90% green energy hydro, basically. You get into the greater Seattle area and you're down to about 75. You take Washington State as a whole, and it's down in the 40% range. And so the energy efficiency there isn't so much, what does it need to be for that building, but you also need to avoid having the duck curve where you've got these peaks in the mornings and the afternoons as you're bringing the building up to temperature and, the afternoon drop off. So it's not just about the energy efficiency, but it's where it uses it and how it flattens it and how it gets the demand on the grid so the grid can still keep up with it. So Dwayne Johnlin has been, chair at SDCI, Seattle Department of Construction, and he's also been chair at ICC Energy. And he has certainly had a lot of drive in this. And his logic is, if you want to get off fossil fuels, you've got to stop using fossil fuels, which means taking it to electricity. And lots of parts of the country are greening the grid in various different ways. But we've got to avoid the point where we actually overload the grid by creating the buildings which are heated and cooled in that way. So it's not just pure energy usage, but it's also a balance of how that's going to affect the grid when you go off fossil fuel.
Russ, I guess what I'm trying to get at is the energy, is it a chicken or the egg kind of game? Like, are adequate energy codes and principles and code jurisdictions and enforcement going to enable healthier building practices? Or is it more of like a cultural sort of, who are the players in the market? What are the trends type of thing? Because you ask people about the general quality of building in New York City. I don't know your opinion, but I think many think it's subpar or below what you would expect for such an advanced geography or area when it comes to architecture and pushing the envelope. How do you see New York City building practices? Is it below? I mean, I know the answer is going to be yes, but is it below what you think it should be?
Well, I think in New York, it's evolved just as it should and has in so many other places, from all glass buildings to buildings that are more intelligent about where the openings are, what the design entails in terms of the overall envelope performance versus the energy that's being used as part of the construction and as part of the building use over its service life. That's all well-trodden ground. But to answer your question, especially as we are sometimes as EOR for the curtain waller, the construction quality ends up having a big impact. And it's a matter of sort of inheritance, I suppose. Perhaps people are thinking about it. It's a matter of understanding the sort of inheritance of all of the actions and decisions we make that results in a building. That you might say people end up finding themselves spending much of their time on looking at the glass itself, but the glass was part of a decision that was made all the way at the beginning. And I think that trying to get a better U value out of glass is there's a full stop to that. There's a point after which you can say you just simply shouldn't make it glass if you want it to be thermally efficient. And so I would say that the people who are working on the energy side are, pushing in the right direction. And I think that buildings have changed over the last 10 years. Nobody should disagree with that. But I don't think that the decision-making process from the owner all the way to deciding what color the glass should be and whether birefringence is acceptable is it's not holistic. And I would say, I don't know if that's true in other parts of the country, but I'd say in New York that there are opportunities to do it well, and there are people who are fighting the good fight.
Yes, don't disagree at all. And I don't want to misinterpret what you just said, but something stuck with me. You said at some point, if you want a good enough R value for your wall, or forget U factor, the equivalent or the inverse rather, you shouldn't be using vision glass. Is that true though? Or do you think, all these people that are, and I don't want to name any specific suppliers or glass technologies, but there's all these people that say we need to push for an R10, curtain wall or
Sure.
overall wall area. And you do have extremely high performing unitized curtain wall systems, whether it's integrating a lot of spandrel area, or it's well thermally broken, or, it's gasketed properly. So we're still at double glazed assemblies, not a lot of triple glazed units that are going up in New York. I mean, there's some, but I'm talking the bulk of what's being built. It's still business as usual to use double glazed with a single low E.
Yeah, I see that. And I think a lot of what I just said is probably missing and not recognizing the efforts of many, many people to try and beat that. What I'm saying is that whether you use triple glazing or double glazing or any of those sort of incremental improvements that you have in making a thermally insulated glazed system, there's only so much you can get out of glass before having to weigh that against the carbon footprint, against the risks of serviceability, with the additional seals or whatever it might be. I think that if you look back through the history of building construction, there have been eras where buildings have had a balance that has had actually a more optimized energy performance, almost as an artifact of the decisions made on how to build. And I think that
actually changed the style of the building at the time.
Absolutely. Yeah.
Yeah.
Yeah, absolutely. So I remember hearing that it's about 120 years ago when buildings were actually the most thermally efficient. And we can get into architecture history and talk about the sort of evolution of glass in architecture and realize that there were points where it was the absolute opposite. Just totally the opposite. No names named and no projects mentioned. But what I think we have an opportunity to do with what we have available to us and what we do push with glass, whether it's VIGs or other things like that, is to sort of put the whole picture together. And again, when you're working on projects that are sort of economy proof and for a reduced, limited number of people, the concentration, I don't know if this is always true, but it invariably veers off the path of the ecological impact and veers onto the path of the resulting performance in terms of aesthetics, weighed against the thermal performance. I find it sort of flips.
Yeah. And there's also the economic, part of it, because there's the build cost in it.
Well, that's what I want to get to, because, I know that Richard and I are still getting to know one another, but Russ, I know the clientele you work for. I know the project typology you work with. It's a sliver of the exception of the type of project you'd imagine. And they're always pushing, trying to do something unique or new. I've been on the contractor side, I've been on the manufacturing side, and I see what it's like to try to survive in the glazing world today. So if you're a contractor bidding, if you're a glass supplier, if you're a window manufacturer, curtain wall supplier, how could you not look at every VE option possible to get yourself on that job? And focusing on that economic sliver that Richard just mentioned. I mean, my God, like to this day, I'm asked to look at projects where they say they want to go with a single line of caulk. And I've said that it's not a joke at this point. I've said that comment a year ago on this podcast. I said that comment 3 years ago. Like, it's still happening. New construction projects, university projects today. If that's the decision that's being made, but on that same project, the architect is going through 17 paint chip samples because they can't find a powder coat match that they like to match that. That's what's happening today. Like,
I'm going to track a little bit back to the whole discussion of, why is Seattle driving where it is, and how does this play out? Because, when we look at one little microcosm and you start saying, okay, how does the glass supplier get on the job? But, how does it work in the bigger economy? When I was leaving Australia about 20 something years ago, okay, we went to what was called a 6-star system for residential, and it was actually brought in by the Conservative government of the day, who originally wanted to kill this green stuff as being economically silly. And so they went into the macroeconomic models and they put it in there, and they realized, actually, when people build things and they use 20% more energy, that's actually just dead money that is a drain on the economy. They work out actually that the payback period was about 5 years on doing the green building. Yes, if you start off and you're doing these sort of leading edge projects, it adds 25%. But if you make it regulated and that becomes the common product, then the ad becomes 5% because it becomes the routine material. And then what they did is they said, well, in the transition period, we'll provide this stimulus of 5%, and then we'll get this payback within 5 years. And so looking at this bigger, broader cycle, people going, economic stimulus for COVID, everyone got $200. Now, imagine if you do that on your energy bill every month, the cumulative effect for the lifetime of the building. These things actually have a bigger effect. And this is where, if people are thinking about it from a regulatory point of view, they're not just thinking about it of, how does the building perform? They think about, how does this money is it good money or is it dead money? And if it's dead money, it's just a drain. And
isn't it a question of penalize or incentivize? Meaning, are we incentivizing with some form of credit, or are we penalizing with your local law 97 fine?
What they're trying to do is incentivize it to the point where this new technology that's more efficient becomes more common, and the price differential starts shrinking because the more suppliers are playing in that field because there's enough of a market for it, and then the more competition you get, the lower the price comes. And so what you're trying to do is drive it in that direction. And sometimes, until you get to the point where room side low E, a second low E, or a triple with a thin in the middle, or a heat mirror, or whatever it is. And still, till that becomes a more common product, then the price cost becomes greater because there are not so many people making it. And so you end up with this VE process that comes back into, well, this is what I can get the cheapest because it's the most commonly available and it's the most competitive. Some of these things, yes, it's going to cost some more, but how much more? Like Germany, you can't buy a double glaze unit. Everything's triple. And they're buying gas from Russia. They don't want to. It's a political thing as much as an environmental thing. So the broader sense of what we're trying to do with buildings and why we're trying to do them is that there's the picture at the glass level, there's a picture at the building level, there's a picture at the building site level, there's a picture at the economy level. And some of these things may not make sense if we look through it just that little. Why are we doing triple glaze in Seattle? The climate, it makes much more sense to do it in New York than it does in Seattle. Mm-hmm. But it does actually make sense in a grander picture of what you're actually trying to do to shift the industry forcibly towards things which, as a country, we're going to be in a better place if we do it that way.
All right. Aside from the thermal now, a lot of questions on that, but I do want to get to the topic because I don't think we talk about it enough. The reach of where hurricane specified products are going to be required, evolving over time as we see weather patterns and climate patterns changing and evolving.
I can say we're seeing it every day. We see it all the time. We're accustomed to it. We understand what the navigation of it is, and we understand that a lot of companies are trying to meet the demand. Maybe there's, our experience in our current project list makes it such that we're being prompted to look at these things too. I can't tell you how many times we see engineering, I can't remember what the right term is just immediately, but basically re-engineering an NOA from one project to another. It happens all the time. And it's very, very interesting to see because they all follow the same pattern, and you can find the problems with them almost immediately by just tracing the pattern of taking a large panel that's been tested and then seeing how it's interpreted into a project. Very often it's very straightforward, and then there are times where you just see a gaping hole. One thing I would say about it is that making an interpretation off of a test very often is effective. But the difference between that, it should be obvious, is that when you're making an interpretation off of a test, you're taking a lot of things for granted, which is different from running a set of calculations. Running a set of calculations and actually following the load path is a different process than simply saying it worked here, and if you make it smaller, it'll work here as well. And obviously, intuitively, that makes sense. But I can't tell you how many times we've seen that something has just been overlooked, and it needs to be checked out in the right way. I've been associated with projects from Hawaii to Long Island down to Florida, and they're all sort of following that trend. And we're finding the ins and outs for every iteration as to how it can work and how it really needs to be looked at a little bit, a little bit more scrutiny.
And the weather patterns are changing, and
Yeah.
we're seeing more severe things happen in more places. We're seeing some people specifying hurricane glazing, where really what they're looking for is retention of the glass if it breaks.
Yes.
And the degree of retention that you put in that, it's a simpler question. So you don't necessarily go to a full hurricane assembly just because you want to have your building not become voided by a piece of glass breaking. This is actually one of the things which is important, is not just how the glass shards come in from an impact and why you put the laminate on the inside, but also so that you don't have the building depressurize or
Yes.
pressurize and blow the roof off, and then all hell breaks loose. So that was one of the big problems with cyclones down in Australia is, as soon as you lose one window or you lose something, the whole building gets pressurized in a way where it's not 1x, 2x. And
Did you
all
just say the
sorts of
word
things.
cyclone?
Yes.
Yeah, but the missus is from Australia, and I don't even know what a cyclone is, so I'm gonna have to be
Okay, so we get
educated
hurricanes here, you
tonight.
get typhoons in Asia, and you get cyclones in Australia. They're all the same thing.
Got it. It's just a funny name for it.
I thought it was a really cool ride down at Coney Island.
Well, it's the spin. It's the same thing.
Russ, do you
Yeah,
have, when it comes to glass
and yes, it does go the other way.
Yeah.
Sorry.
when it comes to glass retention, do you have any opinion? Well, I understand what will and will not pass a test as it comes to hurricane impact, but do you have any opinions on dry glaze systems versus structurally glazed systems, just as like a standard practice and means of assembling a glazed unit? So far as to say, you go to some European fabricators and everything's dry glazed. You come here, a lot of it is wet glazed. From a performance safety across the board, if you had to be like, I like this, I don't like this for these reasons, what's your initial response to that?
Well, we do see, just as Richard had mentioned, we do see clients who are saying, I don't want an impact. I don't want an NOA system. I just want to be able to have post-glass retention. And there are a few ways to do it. It really depends on the system. It's possible to have post-breakage retention under full hurricane wind loads with wood framing, for example. It's absolutely possible to do that. Generally speaking, when we do improved impact performance as opposed to sort of running the full gamut, we typically see if an SSG will be of benefit. It really depends on the details, but if you think about it, blast design of glass typically involves SSG. And so with that magnitude of force and the sort of resulting load path, it makes sense. At the same time, we have reviewed and approved systems that don't use structural silicone glazing as part of a system. It really depends on the stiffness, the post-breakage performance of the glass, and what the rebate dimensions or what the rebate details are. I think it can be done either way, but very often SSG is sort of a fallback.
I would say that for people that are using triple ply lam on the inboard side, if you whack it, one, it's very difficult to break the inboard light just by hitting it. But the second one is you've got 2 layers of interlayer, and it behaves pretty well as a membrane, even if it's in a dry glaze system. If you've got a 2-layer system and it's working really hard, I like to see the SSG in it there, because then you're actually building the membrane action. If you got the sacrificial one, it breaks, falls away, takes a hit. If you get a second hit and you start breaking the second layer, then you're really relying on the membrane action of the interlayer itself. And that's when holding at the edges makes it much easier life on the interlayer. The thing that I'll say on the downside of SSG is the Achilles heel of fully tempered is the edges. And if you're leaving it exposed in fully tempered, then you're not protecting the bit that's most likely to break if you hit it. So in my world, if you had like a curtain wall system that's structurally silicone glazed and it still has a cap on the outside protecting the edge ½ inch, that's your most robust system that you could build in a hurricane system.
So you don't really think about these things until you live it. And oh wow, now that I think about it, Russ, the building I live in, and I don't like to expose names and project teams and this, but you've worked with this curtain wall supplier many times before, I'll say that.
Okay.
Freezing cold at night. Oh man. I mean, and when was this built? 2018, maybe. So it's not new construction, but you feel the difference. And so when you have to explain to a non-industry member or non-technical folks some of these principles and you can feel it, oh, now I get it why you talk about that stuff so much. Starting the home purchasing process, or at least looking, and I've been thinking a lot about the safety element and thinking, you know what, if I'm traveling and I'm not home, I like the idea of having laminated glass, at least on the ground level. I don't know if that's reasonable. It's probably not reasonable. But do people consider and take that into effect, the ease of breakage, the safety element, especially when maybe it's a different discussion in residential versus commercial, but I know you do a lot of higher end, maybe podium or ground level work. Is that a discussion point?
Yeah, for me it is. Absolutely. You have to weigh the performance, the architecture, the setting conditions, and again, visual aspects come into play as well. I don't know how many times I've seen projects that have one manufacturer above the podium and another, or fabricator, and a separate fabricator below the podium, and the appearance of the glass is significantly different. Whether it's wobble, or whether it's how it's set, or whether it's how the edges are dressed. Edge step is it just screams out, and I think that when we work on projects, our experience and the things that we've learned over the years prompt us to ask questions that go beyond what a normal engineer of record would ask. Like, have you considered edge step? What's your arris detail? What happens at the stair where you turn the corner? All these other things. And we actually write into our documents certain things. And I'm sure other people do this too, if not the fabricators themselves, what our recommendations are so that they're on record, to make sure that people are sort of, they're given the opportunity to make a choice. I don't know if I'm digressing, but I really think that we take the opportunity to show the differences based on our experience so that people can make informed decisions.
I might not be lucky enough to see this part of the industry, but is there any use of like VR, AR to put your headset on and walk around at the podium and see these visual differences for you to be able to communicate to your clients?
We've recently been introduced to something by a glass manufacturer that is VR based, where we are apparently supposed to see the difference between different coatings and different project settings. And we're very much interested in looking into this to see if it in fact bears out. I think we're planning on doing on at least one project on Fifth Avenue is to use the VR and to order samples and to do all of the standard stuff, and to try and make a comparison. It's the same way you do a hand calc and then run a model to make sure that you have convergence in the results. So we're planning on doing that. How it will play out, I'll have to let you know.
One of the questions that I get asked, and you're talking about buildings, is, do we heat soak test? Right? Okay, so there's
We've been down
physical risk and there's commercial risk. Which one are we in? And it's like, well, if it's easy to replace it with two guys and you can bring it in there, that's a commercial risk. But if you've suddenly got to bring a crane in there, and that means ripping out the landscaping and everything else because the piece is too big to handle by a group of guys, then that changes the equation, even if it's laminated. So thinking about the context of the project itself is so important, because it can change the decision, and then you can give that information to the client. They can think about what it is. They don't come back at you later and go, I put this really big piece of glass and it's broken, and now you're telling me it's not covered by warranty.
But this has got to be challenging when you're trying to help clients make 30, 40, 50-year decisions, right, and the surrounding landscape might be evolving.
Yeah.
Yes or no? Am I wrong there? I mean, think about New York City, you kind of know what you're getting into, but some of these other areas, the landscape could vastly change in 7 to 10 years.
I'm thinking about even residential projects where they're sort of going, do I want to heat soak test this? Because it's personal money, and do I want to spend this money on it? And I guess go, well, can you easily replace this unit if it breaks? Conversely, I had a project in Calgary where there was some early nickel sulfide breakage, but because of the climate, they couldn't get a BMU out there until the next summer. So there are considerations that come with the buildings and the experience where you just go, you might want to think about it here.
What's tough is, and I know you both aren't going to want to hear this, and you both wouldn't put your stamp on a building like this, but I see a fair share amount of annealed when it's not required to be safety glazing. And Russ is thinking, because maybe there's a place for that, but it's the reality of what's still happening today.
Well, some people will.
Annealed insulated. I'm not monolithic lights, but you have a transom at the bottom. You want that bottom to be safety glazed, fine. But the upper unit,
Well, in terms of visual distortion and anisotropy, it's the way to get rid of it. So, from a visual quality point of view, as long as your thermal fracture is surviving and you're adequate strength-wise, it'll be the most beautiful piece of glass if it's in annealed. It'll be the flattest. So there are reasons for doing it. Every single type of glass has its pros and cons. And we could start talking about what energy code's doing to spandrels and why we should be doing thermal stress analysis in those guys as well. I think that's the next epidemic that's coming down the line, because there's enough telltales out there to say that there's a problem. But the standards we have in the US aren't dealing with IGU thermal stress very well at all. We've got the ASTM for monolithic glass, but not for IGU. And they started doing an ASTM on it about 15 years ago, and I don't think it ever bore fruit. And so at the moment, the French standard is probably the best accepted one. It's been out there for 25 years, and it's adequately simple and adequately accurate. It's not super simple and it's not super accurate, but it's adequately so on both counts, and I think it's a good compromise. But we're seeing fritted spandrel units breaking, and we know that the frit is only diminishing the strength by a certain amount, which means everything else is within that limit. And we're much closer to that line than we think we are, because we're now putting 6 inches of insulation on it, plus mullion wraps and everything else that we need to do to try and get the U value up on the opaque area as much as we can, wherever we can.
right?
And there's no heat release to that box, and you can boil water in it. So the glass is now, if it's heat strengthened, it's getting a much harder time than it used to.
I know, Richard, we're gonna flash your book on the screen, and we've been doing our share of promotion on it. Russ, anything new you're up to, or anything you want to share with us? It's always a lot of fun having you on.
I have to tell you that I've had very, very good feedback from the article that we published in Structure Magazine in June 2021. It's just a very straightforward paper on fracture glass fracture technology, and it has drawn clients. And it has been a reference document that we've been able to give to people when we've done investigation work. And other people have told me that they go back to it when they need to answer a question. So that's not new, but it's something that recurs for us quite a lot. And so I think that I would suggest that if anybody hasn't seen it who is interested in that they take a look at it. I'll just touch upon something that you mentioned before. We do find people asking us to use annealed glass, and there are times where we consider using it. Richard's mentioned this a few times already. You have to navigate what a client is looking for versus what a contractor wants to provide, and then put that in the context of the actual technical requirements in order to know what the glass specification needs to be. And I suppose we might be using VR to help us understand those things, and using, again, just going back to first principles to understand what is required. But I really think that in the end, the glass specification process is one that does require significant interaction. It can't be just a phone call or an email request and then a 1 foot square IG sample review. It's where this is one place I can say for sure that technology has allowed us to push further than what was being done previously. And we are finding ourselves on projects where it really does come down. It starts at the beginning and it goes all the way to the end. And maybe the sampling process is not at the end, but it's somewhere in the middle where we get to really give our clients a keen understanding of the difference between the appearance of the glass and the solar heat gain coefficient, for example. And I'm going back to it again, but how many times have I seen where a frit is absolutely abhorrent? I don't like the color, I don't like the pattern, I don't like the percentage, and then you put it in context and everything is forgiven because there was never a crime committed in the first place. I mean, I'm not promoting for the Frit Association of the United States or whoever is doing that. I'm just finding that there's an interactive process that we're finding on projects that is not just simply specifying a 1-inch IGU that makes for the most successful results.
Great ending note. Thank you both for coming on. It's a lot of fun, and looking forward to next time.
Okay, speak to you soon. Take care.
Thanks,
Cheers.
guys.
Bye.